Earthquakes can cause huge amounts of death and destruction. For this reason, understanding them is vitally important. Like all major events, seismic or otherwise, they have to start somewhere. The epicenter is the place on the Earth's surface under which they start. There are two important locations in any earthquake. The most important is the hypocenter or focus of the earthquake. This is the point where the earthquake truly begins, deep under the ground and located at a tectonic plate boundary, the border between two of the fragments the Earth's crust is broken into. It is where the plate boundary begins to rupture. The epicenter, on the other hand, is the point on the Earth's surface directly above the hypocenter. This is a more useful measure for human reporting because it can be shown on a map. The epicenter is usually the location where the waves from an earthquake are most intense, and as a result, it is also the location with the most damage. But this isn't always true. If an earthquake is particularly large, it may run across a large section of the plate boundary. In this case, the epicenter might only be one of many hotspot locations, and damage could be greater elsewhere. In a 2002 Alaskan earthquake of magnitude 7.9, the greatest damage was 330 kilometers away from the epicenter. The epicenter was at the western edge of the rupture, but more damage occurred at the eastern edge. Scientists have come up with a number of ways to figure out the location of an epicenter. The simplest requires the positioning of seismographs, equipment that measure the strength of ground tremors and earthquakes around the area. It is possible to use a process of triangulation to figure out the location of the earthquake. This hinges on the fact that there is a lag time between receiving the first waves of an earthquake, called the P waves, primary waves, and the latter S waves, secondary waves. Since we understand how these waves work, we can use this lag time to calculate the distance from the earthquake to the seismograph. Larger distances mean greater lag times. Then, by drawing a circle around the seismograph on a map that represents the distance, you can narrow down the location. 3 circles from 3 seismographs will overlap at the location of the epicenter.